Hey folks, Quilly18 here, and welcome to a new tutorial for Unity. One of the things I get asked about a lot is for help with unit selection, which actually seems like a relatively easy question, isn't it? How can I tell if a unit is selected, both in terms of what's the correct way to actually sort of select the unit in code, like having a mouse sort of go over and click on a unit and have it do something, and also how do I represent that visually? How can I make it look like a unit is selected? There's actually quite a few different ways of doing, well, I guess both parts. And so what we're going to do is we're going to try to quickly look at a few different ways you might want to approach that in a relatively realistic sort of program setting, right? There's certain ways that you can do a unit selection, like is the mouse over a particular object in Unity, that works fine if you've got a very simple program. But as soon as you add a little bit of complexity to your models, things start to change pretty dramatically. What do I mean by that? You're thinking, okay, well, I want to know if my mouse is over one of these units. By the way, these are licensed under CC0, so they are included in the project. I even got the source in there if you want to do your own stuff with chess pieces. You might think, yeah, so I want to know if my mouse is over one of these pieces. Well, the obvious way of doing that, so this unit here, both unit big and unit small, have a component on them. They have this unit script. You're like, so what I'm going to do is I'm going to open up the unit script over here, and in it, I'm going to use, I don't know, one of these void on mouse over, on mouse enter, on mouse leave, on mouse down, on mouse up, right, to detect mouse click, one of those built-in Unity functions. And that will often work relatively well for a really, really simple setup. But really quickly, you'll start to run into limitations with that. One of them, for example, is the way units can sort of block each other. What if you have different modes that you can be in the game? Sometimes you're selecting units, sometimes you're trying to attack units. What if you want to filter friendly versus enemy units? What if you have, if this is a real-time strategy game, what if you have buildings? Sometimes you want to be able to select buildings, but sometimes you only want to be able to select units. Like, can you start to imagine those sorts of situations? And the OnMouseOver components of the game object, right, which I'm trying to remember. It is part of game object itself. Hang on. Oh, it's part of mono behavior. Yeah. So it's derived from mono behavior, which is fine. So these on mouse over and whatnot are only going to work. You don't get to filter them. So you don't have the ability to say, if you've got a situation like this, where let's say you want to ignore the units. You're in some sort of mouse mode where you don't want to be able to click on a unit. You're actually trying to click on the ground behind the unit because you've got some unit and you issued the move command, right? Again, most RPGs and most RTS games will have the ability to like issue a move command. And I don't want to click on the unit. I want to click on the ground behind the unit, but it's in the way. Yeah, I can move the camera around or whatever, but sometimes you might want to be able to filter what you click on. And on mouse over and all those don't really give you that ability. Furthermore, on mouse over only works for objects that have colliders themselves. So by default, let's say, we've got some sort of 3D cube over here, right? We've got a cube, and this cube has the collider on it. If I turn off the mesh renderer, we can see this is the collider that's left over. So it's all part of the same object. But it is often, especially as your programs get slightly more advanced and your characters get slightly more complicated, usually, or not usually, but quite often, you might not have the collider on the base object. Like you can see, unit big here, this green bit, that is a collider. That's a capsule collider. But you can see it's not part of the base object itself. Instead, and let me start with unit small. I'm going to expand that, and we can see unit small has two bits inside of it. It has the king, which is the model. This is the visual part of it, right? I can turn that on and off. You can see that it's not there. And it has another collider object over here, capsule collider. Now, I could have taken this component and put it on my root unit, and that would have worked fine. But what if, instead of using this capsule collider, let me turn that off, what if we're using the mesh collider of the king? And again, if I turn off the mesh renderer here, we can clearly see the collider, the mesh collider of this king. And this logically really belongs quite well to the visuals, because one of the advantages of doing it this way, you can put a mesh collider on the base unit, but then you sort of have desync between the visuals and the base unit. And you don't want the visuals to be on the base unit, because what if you change the graphic? What if your graphic designer comes back with a way better model of the king, or decides instead of having chess pieces, we're going to have, a person, a model of a person with a crown. Or maybe you want to have different graphic mode options for your game where you can cycle between different types of models. So you don't want to have to replace everything on the base one. You just want to be able to swap out the graphic set. And so all of this leads to you really, as your program gets more complex, try not to have your graphics and your colliders on the base object if you can avoid it. Try to have it as a subpart of things. I'm going to turn off this mesh collider. We're going to put the capsule collider back on there. So this is a much more reasonable and flexible. You can make changes to this a lot more easily if you've broken it down, but it means that your unit script, which is on this base bit, actually can't do OnMouseOvers and stuff anymore because unless they've changed in the latest version of Unity or I'm misunderstanding something, I'm pretty sure it simply will not respond because those only work on the object that actually has the collider on it. So lots of reasons for not using OnMouseOver and such. So what is our solution? Well, instead, you use a sort of a centralized script here. Now you could, okay, here's the thing. We could still put a component on here. We could put something like, unit hitbox component on here. This thing could respond to OnMouseOver and then send information back up to the parent unit. But it starts to feel, and it's a little cumbersome. And what happens in the case, like unit big, where you have a complex collider? You don't just have one collider, you have multiple little sub-colliders that maybe move as the unit animates. You have a different little hitbox for like the weapon and the head and different things like that, and it's tied to the bones. It's not a mesh collider because it deforms, but you have, and mesh colliders are quite complex in code. You will want multiple primitives. You're using multiple primitive colliders to act as your collider. So all these things lead to, listen, this gets really screwy. This whole sort of unit hitbox script, no, it's no good. It's much, much simpler in the end. Slightly more set up initially, but much more simpler in the end to have a sort of centralized mouse manager. And this centralized mouse manager is simply every single frame. It's going to figure out where your mouse is, and it's going to do a raycast out of the camera. We've done this lots of times towards the object, and it'll know what object gets hit. And that raycast can have layer filters applied to it, so you can ignore certain things if you want. So for example, here, the mouse manager, with it selected, you can see I've got a little public field in here for selected object, and as I mouse over an object, hey, I've got unit big selected. Now I've got nothing. So I don't have to click. I'm just doing it. If you mouse over, it selects it, which is fine for a little demo. So unit small, unit big, boom. It's not selecting the background, the plane. In this case, it's simply because I don't have a collider turned on for the background, but I could. All right, so now, there, ground, big, small, ground. There we go. So we have a variety of different things going on. I'm going to turn it off for the ground just because it'll keep our little demo a little simpler. So let's take a look at what this mouse manager does. It actually doesn't do very much at all. First thing it does is it gets a ray. And what this ray is, it's going to be a ray, the origin of the ray. So a ray is some sort of beam, right? The origin of the beam is where the camera is, and the direction of it is going to be based on where the mouse is on the screen. If your mouse was literally right in the middle of the screen, the direction would be exactly equal to whatever direction the camera is facing in. And if you're doing a first-person shooter, you can just do a ray using the direction that the camera is oriented in. That's it. You don't have to use the mouse coordinates at all, because in a first-person shooter, you would just use the point in the middle. But here, we're caring about where the mouse is, and we're using that to determine where the ray is being shot of. So if you're off to the side, it's going to calculate a different direction, and that's it. So at that point, we have a ray, and we've done this plenty of times, or you should have done this plenty of times. You feed that ray into the physics.raycast. And what physics.raycast does is it fires that ray out, and it lets us know, well, two things. First of all, this will return true or false based on if we hit something. If we hit something, this will return true. If we didn't return anything, it will return false. In addition to that, you can take this hit info structure over here, you can pass that in here, and physics.raycast will actually fill that out for you and return that data back in there. Note, there's another variant of physics.raycast, which is physics.raycast all, which would just take in an array, and it returns an array of all the things that were hit by the ray, one after another, even if they're hiding behind one another. Which is another way you can get extra control here, because you can get a list of everything that the mouse is currently hovering over. In our case, we only care about the first thing that we're hovering over, so we don't need to do that. And it's also worth noting that raycast all doesn't return a Boolean. It could return an empty array. If it literally hits nothing, if you're just pointing at the sky, this will be empty. But other than that, it'll always return something. And there's a bunch of different variants of raycast. There's a variant, for example, this one here, that takes a layer mask, and you can use that to filter layers on and off so you can only hit certain things. But we're going to leave that be. So this will hit something, assuming we're here, we have hit something, and hit info contains information about what we hit. And here's the thing, what it will hit is something with the collider. So very much just like your OnMouseOver, it can only hit the actual object with the collider, which in the case of, if we're mousing over unit big, it's going to hit this capsule. This capsule object, this is the thing that it's actually going to hit. So if we were to do, actually let's do that. Mouse is over, hit info dot collider dot name. There we go. Oops, dot name. All right, let me just put that up over here. Let's have that be the first thing that gets spit out. So you'll see when I hit play and we watch the debug log, it's going to say mouse is over capsule, mouse is over collider. So it tells us it's the object there. And we want to know, well, we don't want to operate on this thing. So we want to operate on the thing with the actual, the actual unit bit. With our simple setup, we can simply say, hey, whatever you hit, give me the root object, the rootmost object of whatever we hit, which in this case will be unit big or unit small. Note that does not work if you decide, and this is something I do very often, if you decide to have something like a big giant parent object called all units, and you stuff all your objects in there. Because then what will happen, and we can actually see that if I've got the mouse manager selected and we pay attention to that little selected object, as I mouse over something, it's going to say all units is the selected object, because transform.root will return that. If you have that kind of setup, which is actually really good, then instead of being able to go transform.root, instead what you'll have to do is you will have to go and iterate through transform.parent and work your way up the chain until you find the right object, which in our example would be you iterate up the chain until you find something with that's got something get component unit, right? It's got a component called unit. When get component unit returns not null, then you have the right object. Or if you go all the way up the parent chain and you end up with an object that doesn't have a parent anymore, then clearly you are currently mousing over something that has a collider but isn't a unit and isn't something we care about in this particular example. Or you might check for multiple different types of colliders, right? Or of components. You might check, am I over a unit? Am I over a building? Although building might also be a unit in some fashion in your game, right? It's not a character, but a building might still be a sort of a unity kind of thing because it has, can be damaged or something. So you got different ways of organizing it. For us, we can go transform.root and that's going to be fine. And then all I do is I call selected object on the thing that we hit. And if we didn't mouse over anything, I just clear selection. And all these functions do clear, it's got some variable selected object. I'm either setting selected object to the object or I'm setting the selected object to null. And here I'm just checking, hey, did we already have a selected object? And the selected object was the one we're being told to select? Well, then we don't have to do anything. We've already got it selected. We can return. Otherwise, we want to clear the previous selection before we start a new one. Okay, that's great in code. Let's show it. So the way I'm going to show it, step one to show something, is I'm going to cause it to become highlighted. How am I going to make it be highlighted? Well, we're going to modify the material on the object. So our model, and again, here, unit big, I've got it set up as a model with a submodel, and then we've got our actual mesh. Obviously, I don't need that for this particular graphic, but this is very common with very complex art, especially characters, right? Your character model might be made up of multiple meshes, one for the body, one for the head, one for the arms, maybe you have different jackets, different weapons you can swap in and out, all this different stuff. So your unit might actually be made up of multiple meshes, all nested in different ways. So I'm trying to simulate that by something like this, right? So our mesh here is being rendered on the screen because it has a mesh renderer. Right? You turn off the mesh renderer component, it's no longer visible. Mesh renderer is responsible for rendering the mesh to the screen, and it requires you to have a mesh filter, which actually contains the information about your mesh. These two things are, you can't have one without, well, you can have a mesh filter by itself. It's not particularly useful, but you can't have a mesh renderer without a mesh filter. And the mesh renderer itself has a material, and this determines how the object looks. What color is it? Does it have textures on it? Is it shiny? All that kind of thing. And right now I have one material I call it chest material, and we can modify it. I could give it a color. I could make it super sort of smooth and shiny and mirror-like. There's different things like that I can do. But in this case, I'm quite happy with them starting off white. But hey, why don't we make it when I didn't actually close that. When I mouse over an object, let's turn it green to show that it's highlighted. So let's do that in code. Very easy to do. This is actually one of the most common and easiest way to show something is selected. So our selected object, we're going to go, we're going to grab its renderer. So we're going to have some sort of renderer R for our object. Now, can I go selected object dot get component renderer? What? I can. I mean, it's not going to give me a syntax error, but our selected object is unit big, right? This doesn't have a renderer. Its renderer is buried deep below here between a child and a child and a child. And it might have multiple renderers. Again, complex things. Okay, so now we don't want to say, we can't say get component because we don't have a renderer component on ourselves. We want to get in our children, and in fact, there might be multiple. So we want to say get components in children of type renderer. So this will return an array of all renderers in our children. And I don't know, for some reason, I don't think this used to be recursive. I might be wrong, but it is recursive these days, apparently. So it will grab all renderer components in all of our children. The only thing it doesn't do is doesn't do ourselves. Also will ignore any inactive components unless you give it an include inactive flag. See the include inactive? So if we said true, this would also include inactive renderers. But by default, it's going to be 0 if you don't do anything. Or if you pass it false, it won't return anything inactive. In this case, yeah, it's fine. Whatever. We'll just use it as is. So then we're going to say for each renderer are in renderers. Now, we know right now in our object we only have one renderer, but let's assume we want to be, flexible here. So what we're going to do is we're going to grab the material. The material M from the renderer material. Materials is actually an array. You can have multiple materials in an object, and some models will indeed have that. You can have one mesh, maybe, that has metallic elements, leather elements, skin elements, glass elements, that sort of thing. And each one of those is flagged with a different material ID. This is something you can do in your 3D modeling program, and Unity certainly supports that. In our case, our materials only have one material. So we can either say materials 0. This would grab the very first one. As a shortcut, most of the time you just go material, which is exactly the same, literally exactly the same. This grabs the first material in the array. Regardless of whether you have 1 or 100 material, this will just return the first one. Now it's worth noting, most things in Unity you can't just set directly. In this case, yeah, we're just going to grab a copy of the material. Now, right now, in the little demo you saw, if I change the chest material here, it changes everything. Both pieces, because they both use the same material. If I go to change the color of this material, equals color.green, is it going to update the other chest piece? Well, it depends. It depends on whether I set material or shared material. Because right now, both of these chest pieces use exactly the same material. So I could grab from here, I could have grabbed shared material. But I grabbed material, and I'm going to set dot material. And what that's going to do is going to break the link between the two chess pieces. So they'll no longer be using the same material. They started from the same original copy, but I'm modifying a sub-instance of it. So that way it won't colorize the other one. So now if I hit play, assuming I haven't screwed that up, and then mouse over a piece, boom, it turns green, and the other one does not. And boom, it turns green. Right now we don't set it back to normal. So let's go and do exactly the same thing. When we clear selection, first we're going to do, if selection is already null, then we didn't have a selection. We can just return right away. Otherwise, what we're going to do is we're going to loop through all of the selected objects. We're going to find all of its renderers, and we're going to set the base color back to white. So now, boop, 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 boop. Ooh, that's flashing quite quickly, actually. I'm going to do that, and I'm going to get rid of this debug info because it's just spamming the debug log, and we don't need it anymore. Bam. Okay. So now we can tell what object we have selected. And again, right now, I've just done it so that when I'm hovering over it, it's being set as a selected object. But you might want to differ that, right? You might want to keep track of, so right now, this selected object is really like hovered object. And so then you might want a separate thing that is your selected object. All right. Well, let's say public for argument's sake. Selected object. In fact, you might want objects, but let's say this. And then you just, in here, have a separate thing that says if input dot mouse button down. If you just click down on the mouse this frame, then set selected object to be hovered object. Right, so now we've got sort of a more hard selection that is maintained, that only changes when you click down. So hovered object, it's still, we'll do that. We'll keep hovered object. We're going to turn, so this is actually very inaccurate. Well, I can rename this. This is going to be, we're going to call it hover object, and we're going to go unhover object. That's terrible. Let's just pretend there's no clicking involved. It'll be simpler. I'm going to get rid of this. I'm going to call this one back to selected object. So whatever we're mousing over is the thing we're selected, just because it's going to be easier and faster to just demonstrate the different activities. But, you know, hopefully you can get a sense. So now, okay, this is currently selected. This is currently selected. Nothing is selected. Boom, done. Same as if we'd clicked. Makes no difference. Okay, so that is one way to show selection. We can highlight it green. But a lot of things don't do that. A lot of things show a visual sort of thingamabob going on. What is one of the more common thingamabobs? Well, to put some sort of circle or square graphic around the base. Can we do that? Yeah, very easily. We're going to create a new game object. Selection indicator. Okay, it's just going to be an empty. And I'm going to add a 3D object. I'm going to add a quad. And again, it's often a really good idea for all your models, whether, you know, plane, quad, circle, cube, or an actual 3D model from a program, to be within your game object. Because the advantage of doing this is then you can take your quad or anything else. It's not rotated right. Right now, the quad is standing upright. So what I want to do is I want to rotate this one, I believe, along the X. And I'm going to bring it to 90 degrees so that it is flat down. We can't quite tell because the color's bad. Actually, let's go and create a new material. We're going to create a material called selection material. And I'm going to make this, make it red because I'm already using green for something. It'll be nice and garish. I'm just going to apply that material to this quad. There we go. Now we can see it a lot better, right? So now it's oriented correctly. Right? Flat down is what we're looking for. But the advantage is that the actual game object here doesn't have any sort of weird rotation to it. It also works nicely if you have to scale things. Right? Now this quad is nicely scaled up. But again, our base object, not scaled, not rotated. Beautiful. Let's go and just bring it to the 0, 0, 0 point. So we got a bit of an idea about what we're working with. And let's make it bigger. Oh, that's the other thing. So notice, actually, see this weird sort of stripey effect that's going on here? What's happening? This is called z-fighting or z-index fighting. Both our ground plane and our quad are at exactly the same height. Therefore, when the program's trying to render the two textures or the two objects, it doesn't know which one it's supposed to render at any particular spot because they're literally exactly the same coordinates. So what we're going to do is we're just going to bring this up a tiny scooch. Now, we could just bring up our, base object, right? Bring it to 0.1. And that looks fine all of a sudden. But again, then our base object has a stupid, extra 0.1 on the Y. Instead of doing that, we'll bring the quad up to 0.1. Actually, it could be in like 0.1, 0.001. Just needs to be a fraction of a fraction above the ground for all that Z fighting to like go away. So there we go. So now our quad is positioned nicely. The rotation's a bit borked. That was weird. I wonder when that happened. And we can just crush this down. And then we've got this thing that just sits at 0, 0, 0 with no rotation and no scale and just looks well. Obviously, this doesn't look quite right, though. Really? We want something better than that. Hey, I've got a little image that I made. This selection box image. Look at that right over there. Oh, that is beautiful. What if we apply that to our material? So let's go and drop that as an image to our albedo. We're going to set our color back to white. There we go. So now I have this little square, right? Because that's all it was. It's a square like this. It's got transparent bits in the middle that you can't tell in the little preview box. I wonder, is there a way to make it show transparency here? Probably. Anyway, I don't know. Let's just ignore it. So I got this little object here that shows our little selection box, which is cool. That looks a lot better. And so we want this thing to follow an object. Like right now, it looks like this chess piece is selected. Although obviously, if I were to grab it here and move it around, it's not. How do you get that selection box to follow the thing? Well, one way of doing it is to just take this and, set unit small to be the parent of the selection indicator. Now, when unit small moves around, it'll follow it around. That's fine. That is actually a pretty darn strong way of doing it. There's nothing wrong with that. The alternative is we could add some sort of script over here. Let's say we add a script called, a selection indicator. Like this. It's some sort of script. And what it does, come on, is the mouse manager knows what's supposed to be selected, right? So let's grab, we're going to keep a copy of mouse manager around. We're going to grab it at the start. We're going to say equals gameObject.find object of type mouse manager. There we go. We're just going to grab a reference to that mouse manager. And it conveniently, the selected object is public, although certainly you could have an accessor, all kinds of different things for it, right? So we'll have to be careful not to override it or anything. But hey, every frame, what if we just say this.transform? You don't need the this, but I like to do it to be clear. Let's take our transform's position and just set it to be equal to, well, first, if mm.selectedObject not equals null. So assuming there is a selected object, then we will set our position to be equal to the mm.selectedObject.transform.position. And this works well because as long as we ensure that the actual base game object here is at the height that we want, that's the other advantage of having your model inside, because actually sometimes your model might be centered differently. You might have a model that if you were to just center it at 0, 0, looks like this. So it ends up meaning that your model here, you have to like give it a positive thing to offset it. In this case, it happens to be that, you know, the 0, 0 coordinate is on the ground, but you can't always guarantee that. So here it's going to work out well though, because we know our unit small is at 0 here. So our selection indicator, every frame, it just sets itself to whatever is selected. Let's give that a try. Let me take this bad boy and move it aside. Okay? And we're going to hit play. Mouse over here. Boom. Mouse over here. Oh, why does it seem to disappear? Well, it's not. It actually is in the right place, assuming I haven't screwed this up. And we can confirm this, especially if I go into wireframe mode over here. There you go. You can actually see, right? You can see the widget here of our little selection, because the selection indicator is selected in the hierarchy. So the little gizmo shows you where it's centered. So it is in the right place. It's just currently too small. So this was looking really good when all of our objects are the same size. For the sake of argument, let me go and put it where, let me parent to unit big, set it to 0. That way I know it's under unit big. I'm just going to drop it back to the main hierarchy. And let me bring up our model and scale this up. It's like, okay, well that was no good. Looks like somewhere around 7 might be quite good. So let's scale it up to 7 and run it exactly the same way. Let me move it out of the way first to prove that it's working correctly. So I'm going to shove it out over there. Hit play. All right, now it's working, but obviously, oh, and I didn't realize it actually has a hitbox, so it can select itself, or it has a collider rather. We want to turn that off. Actually, we can just remove the mesh collider completely. We don't want it to be something selectable. We could also fix that with layers and whatever, but there we go. So now it goes there, and that's cool. But what's going on? You know, wouldn't it be nice if this square resized itself correctly based on the size of the model? Wouldn't that be awesome? I mean, imagine you have models that differ wildly in size, especially maybe models that instead of being tall like this, what if, and this is one of the beauties of our little thing like this, what if our model was actually something that was supposed to be long, like this, in some way? And we probably have to just move it like this to be vaguely centered to its parent in some way. What if this is the way it's supposed to be? Right? Well, now, definitely our selection box doesn't look right. That's not good. That's still fine, although maybe the box is too big. But this is not, no, it's no good. How do we resolve this in such a way that we're happy? Also, I didn't realize the queen mesh, oh yeah, it is rotated around the Y, which didn't matter when it was standing up, but now looks a little bit funny. There we go. Let's do it that way. That's better. And center it. There we go. So now it should sit around the base, and it does. Good. Okay. So, do we want the square to look differently for these different types of things? Well, how do we do that? Well, we need to figure out how big the object is. Now, that's something we can include in code. I mean, let's imagine, for example, that our unit script over here had some sort of code on it that implied a unit size in the world, which affected other things and also treated itself as a hint for our little preview box. Well, that would work pretty well, but then you'd have to manually maintain that as you change different models. Wouldn't it be cool if we could just automatically figure out what the correct size of this object is? And there's actually something that can help us quite well for that. There's two things, actually. So here we know what's selected. And we know that we can grab, say, all the renderers on this object or whatever. There's two different things we can do with that. If we have a mesh, let's say we have some mesh that we got somehow, okay? Well, mesh has bounds. This describes the size of the mesh. How far, positive and negative it goes on the X, Y, and Z axes. These coordinates are in in the mesh space. Okay, it's sort of local to the mesh itself, which means that depending on how the mesh is rotated or scaled, it's very likely to not coincide with world units, which means it might not be helpful. Even if all you're caring about is just a raw size, like how wide, how tall, how deep is this object? Well, it's still going to report to you in a way that is scaled and rotated locally to the object, which might be kind of weird. It's very common to end up making a model in a 3D program that is like 10 times larger than makes sense in your game world. So you just scale it down, or you go the other way around and you have to scale it up, right? Those two things are very common. So there's that. The other alternative is to have a renderer. Let's call it R. R also has bounds, and this describes the size of the object as it is rendered in the world. Now, these are world coordinates, but it is still really, really, really useful. So let's go back to our quad over here. We've scaled our quad up to, where is it in the world? There we go. We scaled our quad up to a size of 7 by 7. Let's shrink this back down to 1 by 1. So this is actually, and it becomes quite obvious if we look straight down and maybe go into just wireframe view, right? This, you can see the squares that make up the world, right? These are world units, 1 by 1 by 1. And if we sort of just move this around, it's quite easy to see that our quad is currently 1 by 1 world units. So that's pretty useful. Well, if we can ask the system, hey, how big is this? And we can see quite clearly here, this extends out, it's about 3 units big, right? So from the middle point here, it's 1.5 units, so you double that, because that was the radius, and you get that. And we can see, let's say we take our selection indicator, we move it to be centered over here, and if we were to scale this ourselves up to, say, 3 by 3 by 3, it's like, yeah, that looks good. If we have a unit size of 3, that boxes in just beautifully. So you can tell with your eyes here that this is about a 3 by 3 area, so any selection box should be about 3 by 3, maybe plus a little bit of margin. Can we get that info? And the answer is very much yes from these bounds. So these bounds have lots of different values. We can find out the center of the object, which sometimes is a much more accurate way in terms of visuals to find out the midpoint of your object, as opposed to just gameObject.position or anything like this. A gameObject.center. Also, because this is visual, this can sometimes work a lot better than rigidbody.center. There's also extents. This is always half of the size. So this tells you how far something extends in the X direction, Y direction, and Z direction. And it isn't just an absolute number. I believe it's just an absolute number. I don't think negatives would ever make any sense here. That is just like basically, what is the radius of an object? From the midpoint of an object as far out along the X in whatever direction, how much is that? And then there's size. There's also minimum maximum. This tells you the lowest X and the highest X. The lowest Y, the highest Y, the lowest Z, the highest Z, which are not necessarily the same point. But it will tell you those maximums. In this case, what we really care about is size, right? Yeah. The size, either in the X direction, the Y direction, or the Z direction. For our purposes, we can probably, let's assume our object is circular for now, which means X or Z, right? Because X is your left-right, Z is your forward and back axis. So either one of those, assuming that our object is circular, that's what we want. Or maybe we'll take the average of the two. Ooh, I like that. Right? That seems fine. So we're taking basically the diameter in one direction and the diameter of the other. If you're talking about a circle, it's the same. If you're talking about something that's a little bit more ovally shaped, it might be thinner in one way and wider in the other. Actually, I don't know if we want the average. I think we want the maximum of both. Well, there's a couple of different ways to take it depending on your objects, actually, and we're going to look at later on, probably a follow-up episode, different ways of working with this. So let's for now, let's just use the X. Cool. Okay. So let's take a float, call it, it's the sort of radius. Let's pretend, actually not radius, it's diameter. It's sort of the diameter. This only works for like regularly shaped objects. This diameter only works correctly for relatively circular or square objects. All right, so we're going to use that. So we're going to set our position to be equal to the position of the selected object, but then we're going to change our scale. This.transform.local scale needs a vector. We're going to give it a new vector 3. And we're just going to scale everything up based on this diameter. Now, technically, we don't need to do the y. We can just leave the y at 1. It makes no difference one way or the other because we're just a flat image right now. Although, what if we weren't a flat image, our little selection box? What if we had a selection cube or selection cage? Stay tuned. We're going to get to that relatively soon. Relatively soon indeed. So let's say use of unassigned. Oh, yeah, derp. We need to say let's assume there's just one renderer to make this a little simpler. So we're going to say mm.selectedObject.getComponent in children, get component singular. So we're just getting a single renderer, just the first one. If the object had more than one renderer, then what we'd actually have to do is we'd have to actually loop through all renderers and add this, which you can do if you have a bounds, right? Big bounds. If you have bounds, you can encapsulate further bounds. So what you would do is you would start with 1. You would start with this. Then you would loop through every single renderer the object has and add that here, which I guess we could just do. F it, let's do it. So we're going to get components in children. We're going to get an array of these. For each, I haven't tested this. I think I'm not lying to you in terms of doing this correctly. For each renderer R in Rs, whoopsie daisy, big bounds dot encapsulate r.bounds. So big bounds will be the sum of all those things, and then we can just say bounds.size.x. I don't like doing things purely off the seat of my pants, and I might be a little bit wrong about the function calls, but let's see what happens. Oh, equals new bounds. And it can just start with like a null thing, 0, 0. There we go. Hit play, and boom. And boom, much bigger. Now you'll notice the selection box is centered on where the game object's point is, right? The game object for unit big is at coordinates 13.87, 00, which is what this point right over here is. But our selection box isn't quite centered on the visual, which is, again, usually what we want. So again, that's a great example. Instead of setting our transform's position to the selected object's transform position, we're instead going to set our position to be the big bounds center. We want the center point of this visual rendering. Oh, right. Yeah. No, of course, that's not going to work quite right. Because of the y-coordinate thing and that sort of stuff. That is very true. I don't know why that one's off. Hold on. No. Also, I didn't realize this is not actually transparent. The white is actually showing. I'd have to change something on my texture input. That's what I get for doing things a bit on the fly. But let's just go and return to what we had before, because it's working relatively well. And especially if our queen is not falling down, which means we give this a negative 90 degree thing, and we bring the y back down to 0. This should look very well, where we have that size square and that size square. Ooh. Oh. Because of the way the bounds work and the way things are rotated. Yes. Because this object is rotated, when we're getting some of these renderer bounds, they are rotated in a way we weren't expecting, so that X wasn't working quite right. So we will have to do a little bit more work if we wanted this to look really proper. But it's mostly there. If I just put this back to the Z, you can see it's there. This square is definitely bigger than this one, because we know with the previous size, the size that's good for this, it gets completely hidden over here. It would probably look better if our diameter, let's add a wee bit more. Say diameter, let's add a little buffer of, like, I don't know, a half a unit of extra space. I think that'll look really good. Really? A full unit? We could also do it as a percentage thing. There we go. That's better. That's better. We might decide to do a percentage thing, which, because here we're getting more white space than over here. That's what I mean by percentage thing. So we go something like times equal, let's add 25%. To whatever the calculated size is, we're going to increase it by 25%. There, I like that. That's really good. So we don't end up with quite as much there. I think overall that is a very happy number. And clearly we'd have to do a wee bit more work on stuff over here with the encapsulated bounds to take into account a rotation. Because, yeah, I guess this is... it says the render bounds are supposed to be in world space. But that X doesn't make any sense. You know, it makes sense when it's like this. Because this gives us an accurate X. It's just not visually centered the way we want. But clearly, this rectangle is exactly the correct size to handle the fact that this is lying down. But the fact that that X is still like that, when we have it standing up, means that even though it is world space coordinates, it's not really world space. So we'd have to take this rotation into account when doing this. It's possible if I was just using it directly instead of adding it all up together, maybe it'd be fine. I don't think so. Anyway, that's fine. That's good enough for now. Good enough for government work. So we're going to go and put a cut in there. And in the next episode, we will check out a couple of different ways, like the example of what if this was more of a 3D box, which we could easily do. I mean, imagine this quad. Right now, we're setting these stuff based on this diameter. But what we could do is we could stretch this out to be equal to the, in theory, the big bound size dot x, except we know this isn't quite working right. But let's say dot x, big bound size dot y, and big bound size dot z. And assuming there was no rotation problems, and assuming our selection box was a cube instead of a flat thing. Because right now, like, making a flat thing taller makes no sense, right? Actually, I'm really quite confused because these are both rotated by 270. But this one doesn't look all silly and fallen over, only this one does. Which is definitely leading me to be very confused. And my apologies here. The other thing I want to point out that the renderer stats are in world coordinates and don't change with your camera. If your camera rotates around, it doesn't change any of those things, which actually leads to a problem when we go with the solution where things hover over in the GUI. Okay, between episodes, I'll probably figure out the solution for this. These two should be broken in exactly the same way or work in exactly the same way. What the? Let me get rid of this like submodel stuff. So now they both have a queen mesh, like they both have their mesh on the base. This one's got a scaling to it, but that doesn't matter. This one does have an extra level of rotation. Well, hold on, let me just hit play here. No. If I go and put the queen and tell it to be rotated this way again, and hit play. No, it's still all weird. I mean, literally, if I set everything the same, like scaling and everything, it should all be exactly the same. Big unit, you've got no weird scaling, you're moved over. Is that it? If I were to center you, it doesn't make sense to me. If I were to bring you to 0 and bring the small unit out over here and hit play. Oh, whoa, what? That's not what size is supposed to do. That's why I clearly... Oh, right, because when I set this to be normal, it's adding itself. It's counting its own base stats in there. This would not be a problem if I was just using the first renderer, or if I was starting from a base renderer. If I grab the first renderer, set that as the default bounds, and then loop through every other renderer and add it in there. So let me do a quick little change here. Let me change this to say mm.selectedObject.getComponent singular in children renderer. That's why I was confused, because see, you change something in your code and it has an unexpected side effect. .bounds. Let's say I just use the very first renderer's bounds, and in this case we know there's only one renderer. Now everything should look awesome. God, all that confusion that didn't have to be there. And if I take this queen, And let me go and just undo a bunch of stuff in here. Get the queen back over there, get it back to the case where it's got the sort of complex mesh structure. There you go. So the queen's back in here. So again, with the queen being a submodel, everything is awesome. Let me take the queen and put it back down on its side, and then bring it up a bit like that, and then hit play again. Good. And let me change where it uses the center. We are going to use, for its position, I'll make a new vector 3, where the x comes from its big bounds dot center dot x. The y will force to 0, and big bounds dot center dot z. See, this is what I was trying to do in the first place. That looks good. That looks good. Success. Okay, so you probably don't know, but when I did this, when I did the line where it was bounds, big bounds equals new bounds, this sets up a new boundary that has a center point at 0, 0, 0 and an extents at 0, 0, 0, which means the 0, 0, 0 point was always going to be part of the bounds over here. So it was calculating this new bounds as being this area inside of this initial starting area, which is double plus ungood. So yeah, that's it. You can still do it right, but not the way I had written the code. So you can still handle multiple renderers, I mean, but not the way I'd written the code. There we go. So this is looking all right. You probably want to tweak around with the extra margin a little bit. That would be fine. Also, clearly, it stretches a little bit oddly. It's going to be really obvious if I look straight down at the scene over here. It becomes very obvious that the graphic sort of stretches in a little bit of an odd way. But we've got a pretty decent start here for a little selection box. So in the next episode, what we'll do is say, all right, that's all well and good if you want this object to show up in the world. But what if you were using the Unity UI system? Let me do that. I'm going to make a duplicate of my selection box. This is going to be the UI sprite version. So I can go and make it a sprite, right, like this. And let's go and create an image that is this sprite, and it's on the screen. So this is part of the user interface, right? Let me go into 2D flat mode, center over here, grab this thing and move it around. It's part of the UI. It exists on top of the scene. What if we wanted this to do something kinda like that? How would we do that? Well, that's what we're going to do next time. Thanks for watching, folks. See you then.